Time for another pedal again. This is the NUX or NU.X, still not sure how to say that, mod core, and $49.95 on the box is far away from what I paid. I paid very little for this because it's dead. I picked this up mainly because it's got a rotary effect on there, and it's not the greatest rotary effect in the world from demos that I've heard, but it's there. I've got better ones in software on computers and stuff, but it's kind of nice to have them sometimes in the pedal just for a flavour. This popped up cheap enough to pick up. I thought it might be worth a go. As I say, it's completely dead, and if I can suss out what this is without too much fuss and maybe get it working, might be of help to someone else, because I believe it's not completely uncommon for these to pack in. I'm guessing it's something to do with the power supply circuitry. So I'm going to get in it and find out and see if we can put it right. Just got battery on the back just to show. There's a plug into the jack. These have got a stereo in and out, but you can run them in mono, so if there's a power switching jack, I'd expect it will be on the top mono input. No difference, just out of curiosity. And the output, nothing lighting up at all. So let's get in it and see. It's like there's 4 screws on the back. I'll take that out just for posterity. Let's see. Well, they're quite loose. There's someone been in it. Okay. Bodge wire. Interesting. That's got to be factory, surely. So I can see a analog devices chip there. That's probably a DSP. You can see 2 AKM chips there. They'll be either digital to analog or analog to digital converters. RT8267, I'm not sure what that is, perhaps something to do with power. A couple of 4558 op amps. They're right near the outputs, so they could be output drivers, because it looks like they are pretty closely coupled around there. The electronic push button there, because this will be relay driven, and possibly a couple of regulators up at the top here. Yeah, AMS 11175 volts and an AMS 11117 3.3 volts, so that's good. We can check straight away from there if we're getting any output from either of those regulators. Have a ground point there, analog ground. I think this is one board, although I can see a connector there. It's not populated. I can see a connector there that possibly goes up to a board for the controls, because they're definitely not on there. So this is maybe one board. 3.3 only has 58 ohms, that seems low. Let's do some voltage checks. 6.2 is pretty low. Let's just check this. Idiot check, let's just check this battery. There's something pulling that down. Well, it's not the worst battery in the world. Should be enough. Let's see if I have a better one. One here that's a little more juicy. Okay, there's our input side. Okay, so we've got a 5 volts there, I would say, but the 3.3 volt, 1.5 volts, that's not ideal. Let's just get it on the bench power supply and just see what current that is drawing. Getting about 90 milliamps draw there, so it is drawing current. Changing modes making no difference. So the 5 volt regulator's going. I can feel a bit of heat from that, but the 3.3 is really low. Now we're getting about 100. Yeah, they're getting quite warm. I'm only really feeling heat in the regulators. I'm not feeling heat from any other source, but I think something. That 3.3 is hotter than the 5 volt. So something's drawing current through that and pulling it down. Let's just again check that voltage. Yeah, 1.7, 1.8 volts. That's not right. The 5 volts fine. There's something strange with that. So something pulling the 3.3 volt line down maybe. Across that little bypass capacitor there, I've still got that 52 ohms. And yeah, that's shorting to output, so I'm going to have a good look around this. I think if I can't spot anything, I think I'm going to mask this off. I'm going to take that 3.3 volt regulator off and see if there is any change in resistance on the track, because I can't feel anything else getting warm, just the regulator itself. So I can't see whether it'd be another short. I'm just wondering if it is the regulator itself that's gone. Usually something causes them to go, but it's not a big deal to take that off and just see if there's any change. I'm going to assume the one on top as well. No, that one's okay. But this bottom one that comes from the grounder adjustment pin there, which is down to ground, yeah, we've got this 52 ohms. Again, comparing that with what's on, let's go to resistance, comparing that with the 5 volt regulator. We should have a capacitor there which will increase, yeah, 1.19k on the 5 volt side, 52 ohms on the 3.3 volt side. Something's wrong there. A tiny bit of flux on that to get that going. There's a couple of tiny bypass capacitors on that, just the little tiny ceramic ones. I'm going to do my best not to disturb. See what I can do. It's like an awkward way of doing it, but we've got it. And the bypass capacitors are still there. Good stuff, right. That's on there. Let's let that cool down a second. No, it's still there. We still have the same 52 ohms, so it isn't the regulator. We're going to have to remove one of these tiny, tiny capacitors after all. Oh, I really hope not, but I might have to. Out of interest, let's just compare the current draw. Yeah, 10 milliamps. Yeah, 5 volts is still running. Just as a little experiment, I have the power supply current limited and set to 3.3 volts. And if I inject 3.3 volts into that point, it's drawing 30 milliamps. I think I'm going to take the board out, just have a little look. So the next obvious thing I could do would be to take that tiny little bypass capacitor off, but I'm going to investigate first to see if I can see anything else. Everything's surprisingly loose on this. I wonder if someone's been in it. Okay, yeah, I was right then. There's a board for the controls there, and that just flips over on a ribbon cable. That's handy. So we have another chip there, a crystal oscillator. Yeah, it wasn't actually necessary to take that to take that nut off the foot switch, because it's just a mechanical linkage. I'm going to put that back. What have I done differently? Is it because it's not on? Alright, this is a bit weird. The 52 ohms we were getting before is now 208 ohms. What have I done? I've put everything back the way it was. All I've done is loosen the board. What have I done? That's strange. Okay, I'm still drawing the same current. Changing again. Getting slightly different results every time. Is that something temperature based? Why every time I put power to it afterwards do I get a slightly different result? I'm not feeling any temperature change on anything when I do that. So to make that easier, I might solder a tiny wire to that 3.3 volt input. Okay, so that's a tiny bit easier. There's our 3.3 volts. I wonder if there's anywhere I can see this. There's 1.4. If there's anywhere I can see this 3.3 volts easily. Ooh, okay, 3.3 volt there. Is that U11? So with voltage on the board, no change in the current draw. I wonder if I put battery to power the 5 volt rail, because the 5 volt rail should be inactive, shouldn't it? So it's probably not going to do anything right now because we've only got one power rail going. Yeah, 1.4 volts, so something's sort of leaking through, but that's not 5 volts. Yeah, with no 3.3 volt regulator, that should be open, shouldn't it? That makes the current draw go down on the 3.3 volt rail, but still no dice. 5 volts, 3.3 volts, 3.4. I've just done a little bit of reading up on a couple of the other chips. This is a DC to DC converter chip. That's a tiny RAM chip that will be on the bus for the DSP chip. But one thing that's missing is a microcontroller. I can only think, because this on the back is not it, the chip that's on the back, this one is a tiny hex inverter, it's a 74 series logic chip. I can only think that the microcontroller is possibly on this board, because we've got all these controls and the LED and everything on there, and there might be a bus down this cable here, or maybe just I2C or something that communicates with the DSP to control it. So that's a little bit odd, so I don't know, I'll keep going. Alright, just going to a split camera shot on this one because I just want to point something out. After doing a little bit of reading of a few of the chips and such last night, and hooking this back up again, I'm drawing right on the borderline of around about 10 to 20 milliamps, as much as the resolution of my power supply will show, on the 3.3 volt rail into this blue wire. There are test points on this board. The battery is also connected as well, that should be powering the 5 volt rail. There are some test points on this board, and interestingly, 2 of those are for the bit clock, word clock and digital output of the analog to digital chips. And lo and behold, if we look at some of these with the powers all on, that is a bit clock, that's a word clock, and that is digital data. So as well as that, around some of the op amps, for example, if I go, I think, to this pin, you can see we've got a high there, 6.6 volts, around at 6 to 7 volts high power supply on the op amps. So we've got power to things, but no sign of life. Now, what I'd said earlier about the microcontroller being on the other board, I believe it is. I've looked at a couple of blurry photos online, and yeah, I think the microcontroller is right in the middle of that top board. I haven't taken it out of mine yet to see. I just wanted to do a bit of cheeky research to see if it was that first. A slight concern, this bodge wire here, I've not seen anybody else's with this bodge wire, so I'm still not sure if that is factory or someone's done that or where it exists. But either way, I've got a sneaking suspicion that that microcontroller is not running, because if I sort of press the button, it doesn't do anything. There's no sign of life in the LED or anything like that, and don't know if there's any power supply. I haven't checked actually if there's any sort of power on these coming through. Nothing. I don't see anything on the button. In fact, one of these, I believe that one, should be some sort of power, so we should see something there. Again, I don't seen anything go down to there, but we've definitely got something going on there. So these 2 chips at least are active. and these two chips are active. So that must mean that the DC-DC chip is also active. In fact, I might even be able to see. Yeah, we've got a high there, look. Possibly the other side, I don't think there's any way. Yeah, there's our switching output. Let's have a look at the frequency of that. I believe it should be 400 kilohertz. Yeah, 387, close enough. Yeah, 387, 390. So that's the switching output from that DC-DC chip. So that's running. See, there's a 3.3 volt supply right there. That end pin. Going down to the other board. But nothing on any other pin. Curiously, I've just spotted something. When the regulator's in place, the top tab of the regulator would also be live with the 3.3 volt output. There's a pad there that will be connected to that and a trace that goes out to this pin. And because there's nothing there, I wonder if the microcontroller has no power. Because there's a 3.3 volts there, but that could be a logic pin, but this has got a big trace which suggests that carries 3.3 volts. I should probably jumper across from there to there to see if that makes any difference. So it's like the top of our board is active, but the bottom board is perhaps not active. I think what I'm going to have to do is make this wire longer so that it reaches across both, and that might, but you know, while we're there, let's meter something out. Sorry, this is zoomed in and a bit of a tangle with wiring, but I will read out what I get. So from there to there, I get 214 ohms roughly. From there to there, I get 5.96k. So we've got a short on this side of the board, I think, or at least a shorter path. Now, yeah, 209, 210. But we're okay on this side. Out of interest, what happens if I, instead of activating the top half of the board, I tack that to there and power the bottom of the board. It draws no current like that. Then again, I've got the battery on. We had a very tiny blip in the current there with the battery connected. I don't see the light coming on still. Let me try doing that. Connecting them both. Okay, just bridge that across too. Oh, the lights come on. It's working. Okay. Let's just turn power off a moment. It's working. I've got some 3.3 volt regulators on order. After all this, I wonder if we did have a bad regulator, but I don't know. I feel like there is still something odd about the way that resistance keeps changing, and it's low on this side, which should be the logic side, I believe. There's something still a bit odd about that. I'm going to wait until that AMS 1117 comes in the post, put that on, and see if it comes back to life. weird. It's one of those things where I've done something, I don't know what I've done, but there's definitely a change in resistance across that rail. Very, very, very odd. The regulators turned up today. I've got 3 of them. Before I just go fitting that straight off, I've just clamped the meter across that voltage rail just to measure the resistance again, and we're pretty constant there around about 187 ohms. If I press the button in, it drops to about 183-ish. I'm still none the wiser exactly what caused that low resistance that we saw earlier on when it dropped down to about 52 ohms or 57 ohms, something like that. I noticed that if I disconnect the jack there, it goes wide open, so there's definitely a switching contact on the input jack there, so that does make sense. We are bridged across both of the upper and lower board rails still, so that's measuring the parallel impedance across both, but if I remember right, the impedance of the bottom board is about 5k or something, 5 or 6k. It was massive. The impedance of this side was lower, but yeah, I still haven't found a solid reason for that impedance going so low. I have a theory, and I did find a little bit of evidence to possibly support it. Looking around sort of some of the manual soldering on these boards, there's quite a bit of marks and flux marks and stuff like that. They're not cleaned ever so well. When I looked closely a few days ago when I was working on this, I did notice a couple of tiny little stray solder balls. I do wonder if something had wedged itself in somewhere it shouldn't have done, and caused a short somewhere. I did give it a little clean. We've had it running on the power supply and had no short circuits. It is a low impedance, but I mean, it's not as low as 52 ohms. It's not a capacitor charging or anything like that, it's a consistent value. So, and it only drops when I press the button like that. So I think I'm just going to put the regulator on and see what it does. Okay, our impedance with that fitted now is about 152 ohms. And pedal a go-go. Will it stay like that? Who knows? Okay, when it's in process we have no audio. That's a disappointment. I'm not sure what this tone lock setting does. I'll have to look in the manual on that, but nothing coming through. The switch is a bit bouncy as well. I wonder if the button's a bit worn out maybe. See? So it's passing dry signal when it's bypassed. Yeah, that switch is not very good, is it? Might want to replace that. Okay, we're going to go back to the 2 cameras again here. Apologies for a little bit of glare on the scope screen, it's because of where the sun is. I did a little bit of probing around this earlier in the week, and I've just got a bit of time now just to show what is going on. So the 2 chips here, they're not the same. I thought they were the same chip for probably left and right. They're actually not. One is the DAC, one is the ADC. This one nearest to the bodge wire here is the analog to digital converter. The one furthest away is the digital to analog converter. So As we saw earlier, that the bypass, if it's in bypass, you can probably hear from my little monitor there, when it's in bypass it passes a signal fine, but when it's in active, when the effect's active, we get nothing. And I was tracing this through, and I've noted a couple of things, and I can think of a possible cause. Just to sort of trace this round, you can hopefully see, if I get the right side, there's our 500 Hz wave coming in, and if I follow that through to the analog to digital converter, just looking at a diagram off camera here, just on the laptop on my knee, we should be able to see, if we scale it off, just at the top there, it's coming in to the analog input pins, which are pin 1 and pin 2 there. So it's making it that far, and if we look at the output of the analog to digital converter, we've got a serial output on pin 9, which is just hiding underneath this cable here, and if I put that there, get that out of the way, we can see data. So we know the analog to digital converter is running. Now I expect that that data should make it through the DSP chip. This is actually a kind of CPU with DSP cores, but let's call it a DSP chip for the sake of simplicity. Should be making it through that, and then we should see a digital input to the digital to analog converter. So that chip is the opposite way around, so actually pin 1 is up at this one, pin 1 is up at this corner on this one. So again, looking around that, we should be able to see a clock circuit or clock signal, and yeah, if I trigger that, there's a clock signal, 11 megahertz, and there's an 11 megahertz crystal on the bottom of this board, so that tallies with that, so we know it's getting a clock. And let's have a look, do we have a bit clock as well? Should come from that pin. Yeah, looks like we've got a clock there as well, so that's okay. And we should be seeing data coming in, which would be pin 3. And on that pin there, pin 3, we should be able to see data. Now conveniently there's a tiny resistor there that is connected to pin 3 that I can probe from. And what do you notice there? That don't look healthy, does it? That to me looks like a bus conflict. You see it's jumping around, so there's some scrambled data going on. Let's look at the other side of that resistor, nothing, so that's probably a pull down. So there's something going on there, which means clean data is not making it into the DAC. Now also, the ribbon cable that goes down to the bottom board, which has got the controls and the microcontroller on, again kind of probing around some of that, I've found a few data signals, which does make sense. If I can get a decent probe on that. So we can see there's data, and again kind of corresponds with the voltages you'd see in a 3.3 volt power supply. There's another data pin, that's the one we just looked at. And look at that one, again that kind of matches, doesn't it, what we were seeing. And the next pin, again a clean data signal. So after that we've got something that's just a logic high, something else that's a logic high, I'm not certain what they do, I need to find out where they go. Another logic high, nothing on that one, another logic high, something on that one, what's that one? That's a logic high, it's just a bad connection, and another logic high. So yeah, this pin, there's some kind of bus conflict going on. So the DAC is not receiving clean data. Alright, a catch up again, and it's been a little while since I did the last clip on this, and I'm actually refilming this clip because I tried to do this earlier and I was between jobs and I was just kind of breezing through it and I just didn't explain a lot of stuff very well, so I thought I'd do this again. Since I did my last clip on this, I've been fortunate enough to get a schematic diagram from NU.X on this, and it also helps when you go on their website. It tells you how to pronounce the name properly, and it turns out, yes, it is NU.X. A chap called Michael very kindly emailed me back a couple of days later and said, yes, because it's a long discontinued pedal, because it's from about 2012, quite happy to give you the schematic diagram for it. And it did help me identify the signals and the path that are faulty and what exactly they are. This uses a protocol, if you don't know already, called SPI, which I think stands for Serial Peripheral Interface. And it was developed by Motorola and it's become a bit of a de facto standard, and it's a serial communication protocol where you can have a main or master device and then sub devices that they can communicate both ways with, and you can do it down I think it's just 4 connections, so you don't need a full data bus. The output side, on SPI you have 2 main connections. You have one called MOSI, which is master out sub in, and then there's one called MISO, which is master in sub out. And what I'm sort of noticing is that the signals coming from the microcontroller, the opposite board just out of shot here, going into the DSP are fine, so the instructions coming in are fine, but anything going out of this DSP just isn't right, it's all wonky. So there is a MISO signal, which is what is on that 5th pin, that one there I believe. That should be a signal coming out of the DSP and back to the microcontroller. That's one that's all wonky. And the one that's going into the DAC again is an output from the DSP, and that's all wonky as well. And they are, I believe, that's pin 1. Those 2 signals are around about here on the DSP chip. I've been looking around it to see if I can find any issues, and I can't really find any kind of smoking gun or anything to say there's a passive component or anything that's faulty. Also, this chip, this is a static RAM chip that is used for the tone lock feature. So the tone lock feature, I had to look this up in the manual, you can switch it to tone lock and it will either save or recall, depending on how you do it, your setting. And I'm not sure if, because there are obviously several effects, several positions on the effects selector switch, I'm not sure if it can save a setting for every single one, but basically if you adjust it how you want it and then put the tone lock switch on, it will I think it will save the setting, or you undo the power, hold the main switch down, put it on tone lock and put the power in. It's a bit weird how it does it, but there's basically a way you can save and recall a particular setting, a particular position of the dials and everything. So that information must be saved in this static RAM chip, and there's an SPI link to that static RAM chip, just the same as an SPI link to the main microcontroller. And even looking around that, I can find static highs and static lows, but operating the tone lock feature, I should surely be able to see some data, even if it's just a short burst, going to and from the RAM chip. And I don't see any activity, it's just static highs or static lows. So the DSP doesn't seem to be communicating with the RAM. The DSP doesn't seem to be properly communicating back to the microcontroller, which is a little AT tiny chip on the other board, and the DSP doesn't seem to be sending clean data out to the DAC. A couple of other corrections as well. I got this slightly wrong when I thought these were both input or output op amps. One double op amp is input, one double op amp is output. I forget exactly which way around they are, but one's for in, one's for out. And this little chip here, this switching regulator, this gives a 1.4 volt output, which also powers the DSP. So the DSP has a low voltage that gives it a kind of low power state, so it consumes less power. And you get the 3.3 volt input as well, so they each have different reference pins. One's called VDD-X, which is external 3.3. One's called VDD-Int, which is internal from the 1.4 volt supply. This is working fine, it's dead on 1.4 volts. 3.3 volts is obviously now fine. And I think this bodge wire, right under here, there's a tiny reset generator, and I think it might be something to do with reset timing. The reset signals are working fine. I've checked them on the scope, and I know that the same reset signal also goes to the microcontroller, and because that's turning the switch on and off and there's data coming out, I'm led to believe the microcontroller is working fine as well. So it's all leading to look like this processor's at fault. Now, I don't know if it's faulty, I don't know if it's just sort of asleep. I have found a source of these. Farnell have got them, unfortunately, because it's only a £5 odd chip, £5 or £6. They put handling charge on if I ordered one, so it cost me about 18 quid to get one of these chips. And underneath the chip, it's got a ground plane, like a pad, a little bit like the repair that I did on that analog heat, that Electron analog heat, where I had to change the DC-DC chip and it had that thermal pad underneath that you have to solder from the back. This has got the same thing. Now it has got, if we can get it in, it has got this little square pattern here that may be vias, so you may be able to get a soldering iron in, put flux underneath the chip, wick solder through from the other side, but I'm not sure. So either way, and also look how small the pins are. If I've got to change this chip, that's not going to be easy. That's not going to be easy at all, but yeah, I'm trying to still find a kind of definite diagnosis, really, of is this chip dead, is this chip faulty, or is it just crashed or just not waking up properly. It never got hot, can't see any physical damage. I've measured all components in the path of those SPI lines and the signal coming to the DAC as well, which is I2S format, which again is a common protocol for sending digital audio. They're just resistors, and they all measure perfectly. They measure exactly what they should be. The tolerances are really tight on these, and they're great. So yeah, it's just looking like two sets of the outputs here are potentially faulty. I think I'm going to keep scoping around and just have a look at the signals. But it might come to a point where really this chip needs changing. And it's a question of how worth it is, because if that's going to cost me about 18 quid, well, let's say if I'm going to order two of them, I might as well, because I'll probably screw up the first one. It's going to cost me, what, near enough 25 quid. On top of what I pay for the pedal, well, there's a working one on eBay for about 30 quid at the minute. So on the surface, it's not worth doing it. But I really want to see this work. I'm kind of at the point where I've got this far, I've scoped out tiny signals on this thing. I kind of really want to do it, but I'm weighing it up. So a bunch of time later, busy and all, I've picked up another pedal in this series. This is a metal core, and this, for all intents and purposes, was brand new. It is one of the earlier ones, and of course I've got that for the reason of matching it to the one that I'm fixing. As some of them were available fairly cheaply, the original Mark 1s, I thought it might be helpful to pick another up and just compare a few signals and see, because these use exactly the same board and exactly the same parts. It's just that they trim a few of the sockets down for ones that don't need them and change the firmware on the microcontroller. But as far as I'm aware, apart from the apparent lack of bodge wire on this one, they're all, in terms of hardware, the same. Be aware that although I thought this was the case for all the core series, especially in the early ones, There's one called the drive core, which on the side of the box proudly boasts it's purely analog. It's a completely different board, it doesn't have the digital system at all. Ask me how I know. Yeah, I kind of ended up buying one first and then opened it up. Well, I saw a sign on the side of the box which I couldn't see in the eBay listing. It said fully analog, and I went, oh no. So I've actually ended up with 3 of these pedals now, but I might keep the drive core and see if it is any good. I have it on reasonable authority that they're quite decent, and I'll probably be keeping this little metal core. I'm sure it'll be useful. Didn't pay a lot for it at all, and as I say, it was brand new. But anyway, I digress. This pedal works, and I just want to compare. I've already done this, but I just want to show for the sake of the video some of the differences. So actually, let's do this fairly. First of all, our candidate, we know that we were getting quite a low resistance across the 3.3 volt regulator, and yeah, today I'm getting about 160 ohms. Comparing it to the metal core, switcheroo here, again doing the same thing from the ground to the 3.3 volt tab, I get around about 820 ohms. So yeah, huge difference there to start with. And let's again pop the power and a ground lead for the scope on this one and actually have a look at a few signals and do some comparisons. So I'll put the second camera up. Alright, so we remembered that pin 5 on this ribbon connector here, it's got a stinky little signal on that. That looks terrible. By comparison, we should have something like that, touching 3.3 volt rail. It's awful. And also, there's R85 here, which goes to pin 3 on the DAC. Also, is just rubbish. And there were a couple of clock signals, I think, weren't there, around? Not clock signals, there's a reset signal and a couple of other bits that we did test were okay. But it was mainly those two. So let's just compare that with the other pedal. So 1, 2, 3, 4, 5. Pin 5. 1. Interesting. I'm not seeing anything there on pin 5. Any other pin? Well, there's a clock signal. Let's just zoom that there. Oh no. Is that a data signal? But pin 5, nothing. I was actually expecting to see a signal there. Just look down some of the rest of it. The high. Let's go back to the beginning. That's the ground, I believe. That's a supply. That's data, isn't it? Look, you can see it pulsing through. That's data. Pin 5, nothing. I wonder if I could. What can I do? Don't see anything when the button's pressed. Okay, that was unexpected. Let's just look at that corner of R85. Okay, yeah, that makes sense. That's a full data stream into the DAC. I've no audio going into the DAC, but we still see data. But okay, that's looking a lot healthier. This is interesting, yeah, pin 5, nothing. I wonder if that operates when it's powered on. Let me look at the diagrams again and see what that does. It's a signal coming back from the processor, isn't it? It's the meso pin. Everything's very cool on there as well. It's the meso pin, so the DSP would use that to send information back to the microcontroller, but perhaps it doesn't need to send anything back to the microcontroller. I wonder if it does that when it's first powered on. I think to know that, I'm going to have to modify my setup slightly. I think I'm going to have to, instead of the battery, I wonder if I could do it with battery. Actually, there might be a slightly janky way I could do it with battery. I just want to make the initial power on and see if I can see any data on that pin. Oh, that's interesting. There is a very low blip that looked like the data on the other one, but it goes away. Look at that. That's not what I expected at all. Let's just look at the reset generator, which I think was this pin on this little chip here. That seems to be okay. That seems to be doing the same thing as the other one was. And what else can I look at? This RAM chip. Let's see anything different happening there. Oh, so there's something. There was some activity on the RAM chip. Don't think that happens on the other one. Let's just check this one. No, I'm sure it was the same pin. Nothing. Yeah, nothing happens. So maybe whatever's going on with the DSP on this one, it's got it stuck in a boot loop. So I think there is a short in it somewhere, and I do think it's a goner. I think we're kind of at that point. There's nothing more I can really do beyond this other than attempt to remove this chip. We've compared the resistances between that and a working board, and I cannot find any other component that shows any definite symptom of causing that problem, and we know that the chip appears to be stuck in a boot loop. So I'm going to have a go. Worst case scenario, I did consider that the metal core that I've got, if I really screw this up, I could swap the board, the main board, from that and repopulate some of the components, although they're very tiny. Worst case scenario, let's be honest, it goes in the bin. But this is kind of beyond the point really of a economical repair. I've done a few of them. I've gone a bit experimental with this one now, I freely admit, and I just want to see how far I can get with it, because if it comes to the crunch that actually changing this chip, as difficult as it's going to be, actually fixes it, then I'll feel like that's a kind of personal victory, even if a new chip's going to cost me 17 quid and I've had to buy 2 others of these pedals to try and make a bit more sense of this. So I've got an idea. I've got the quite heavy and hot tip on this Metcal iron that I've got. I think I can get from underneath, and I'm curious to see if doing this, if I can get this right, wicks any heat through. So if the distance is about that, can I go, there is a capacitor right near it. The difficulty is I can't see it. And now I feel like I'll have to go back to the old faithful. But I know this could go horribly wrong. Oh, got it. Wow. Got it. Did we lift any pads? Did we lift any other components? We'll let that cool. Pretty good. That was a bit scary as well. Gotta make sure that centre pad is flat and clear. Otherwise a new chip, if we get that far, won't sit on it properly. Right, let's leave that to cool. Some of the flux has migrated this way, as there's a slight angle on this board, but doesn't look like anything else has been disturbed, hopefully. That was a bit nerve-wracking. Just check some resistances then, so we know that ground pad. Yeah, we've got a 0.1 from the ground pad to there. Let's go from the ground to the 3.3 volt output. And yeah, back to 708 ohms. What was it, 0.82 or so. Bearing some differences in probably capacitors. And well, an entire chip missing as well, but on the other one it was what, 0.82k or so about 820 ohms, settling on 708 ohms. Let's just check from the barrel on the side where we were. Yeah, 708, 709. So we definitely had some kind of issue in that chip. Coincidentally, yeah, of course these blades are disposable if you want to screw up a scalpel tip. Blast it with 450 degree hot air. I'm always very careful about using a scalpel to lift parts for hot air. I just like it that the tip is very sharp, very fine, and it's flat. Sometimes you can't always grab things with tweezers, especially if the package is very flat. And sometimes I like to just kind of catch this on one end, and I don't reef it off the board. You just get one end under there and you just kind of do it by feel, and you can feel when the chip is just starting to go, and you don't pull on it again, you just keep kind of feeling at it until eventually it just flips. So yeah, of course the blades are disposable. I've got I think about 100 of them in stock, so I'm going to swap that blade for when I next want it for cutting. But yeah, probably not the perfect tool for it, but if you're careful, I do like using a sharp scalpel. I think it's time to attempt this chip then. I actually attempted this earlier in the week and discovered that I've got no solder paste. So I had to order some and wait the usual time it takes for stuff to arrive. I have to use paste on this because I can't do the trick I wanted to do of wicking solder from the other side. The green solder mask on the other side of the board actually covers the little vias that are underneath the chip there. Little holes go through, although there are plated holes there and they're plated through and everything, and you can heat it from the back. You won't get solder through because the solder mask covers the holes completely. I could tell that by shining light through them, and I could see the green through the holes. So I've no choice but to do this with solder mask. So I've got actually two new chips. The packaging was a little bit outlandish to me, a mere mortal. It came in a great big moisture-proof anti-static bag with an anti-static approval card and moisture approval card, and there's two inside this box. I bought two because it was cheaper just to get two, chuck a couple of other bits on the order, and avoid the handling charge. So if I screw this up, I've got a second attempt. But yes, got the paste, got the chips, and I'm going to do it on a mirror so I can see underneath where I'm going to be putting the iron. And after that I'll have to clean it. I'll have to solder the pins on the side. I'm a little bit nervous about this, but we'll just have to see how it goes. I kind of hope that the paste sort of pulls it into place. I don't know, because if it's not lined up right, I'm not sure whether to tack it. It's going to smear a tiny bit of flux on the bottom of the board. See the flux going. What's it paste melting? It's twisting. Why is it moving? Wait a minute. It's already not going well. Why is it moving around? Oh. No, it can't be, it's miles off. I don't know why it keeps moving. No, it's miles off. The point on this iron seems to be alright with doing that. Drag it. That's still moving. That's still moving. Flux might fix that. Turn to solder now. Oh. 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 It's going. Is it popping? So right now I'm going to get some flux on it. I think that ground pad's soldered. I've just done a quick check of resistance. And it's come up to between 3.3 and ground, and it's come up to about 500 ohms over that. So I think we're doing alright. I think that ground pad has got to have soldered down the way that was all bubbling. There's a through-hole capacitor, electrolytic capacitor on the other side. I might have just caught a little bit with the iron. I really don't care because that's going to be a really easy part to swap. Now I want to get these pins right. So there's some pins that are soldered, there's some pins on this side facing me that have bridged. There's possibly some pins on here that have bridged or not connected, so I'm just going to go around this. Oh, this has been nerve-wracking. You can probably tell by my voice. This is really difficult. It's hardly life or death, but it's beautiful. Let's got that. Don't know if I've actually got solid on that side, truth be told. That sucker is on. That was genuinely really, really nerve-wracking to do. Some people just seem to have a knack with solder paste. They're just really happy to work with it. It always comes, I don't know, really unnaturally to me. I don't really know where its kind of melting point is in a way. It just never seems to go sort of smoothly. And I kind of had to just cheat and just, it's not really an ideal way to do it, but tack one row of the pins down just to get it to stay still. I don't know why it was floating away. And I'm told that if you do them all with paste, the surface tension should balance and it should just pull everything into place, but that was just going, it was going off the pads on one row, so there's no way it was going to just pull itself entirely back. I could see if you were doing something like, you know, one of the kind of small outline package size chips like this, but I think if they're done precisely by a pick and place machine and it goes through a reflow oven or whatever in the manufacturing stage, yeah, all well and good. I was sure I got the board level, but I didn't check it precisely with the spirit level or anything. Maybe you need a perfectly level board. Maybe you shouldn't really be trying to do this in one corner of your kitchen by hand, but what I have. So let's just do a quick resistance check again. Now I've let it cool. I'm a bit too zoomed in to get the meter on the screen, but I'll read what I get. So between a ground point, 3.3 volts. Yeah, 700. Yeah, 710. I'm reading the meter wrong there. 710 ohms, which is much closer to what we were getting on the other pedal, the good pedal. I've had a look around all the pins with my massive magnifying loupe, and it all looks fine. The real star of all this is, it's lost its label, but Chip Quick Flux, not a sponsor, but man, I'd happily do a sponsorship for Chip Quick Flux. It's so good. I was able just, once it was on, I was able just to sort of smother the pins in it really. Sometimes I use a toothpick to do a small amount, and then just got the finest tip on my Metcal iron in the lowest temperature. Actually, I've got higher temperature tip I haven't tried yet, mid-range one, but just the lowest temperature fine point tip. This one might be a bit too close to focus. I just went swip along the side and it immediately sorted it out. And those are tiny pins. I don't know if I'd try it tonight. It's getting a bit late. I feel like I need to lay down after that. I hope that chip's alright, because I really did have to bake it, but that resistance reading's optimistic, or making me optimistic, I should say. I think I'll leave it for tonight. I'll pop the spare chip back in its box and I'll put it back in its barrier packaging, even though I suppose I've breached that barrier now. I don't think it's really going to matter for my needs. And yeah, call it a day for tonight, test it tomorrow. Alright, time has come. I've got current limited supply. I've checked the impedance between the 3.3 output and the ground, and I get roughly 700 ohms, which is in the region of that other pedal that worked fine. I did a check around all the pins earlier on against ground to see if there are any shorts, and there appeared to be a short on one pin, and I cross-referenced that against the other pedal, and the same pin is also short to ground, so I think that should be fine. I think at this point what I'm going to do is cross my fingers and switch it on and see what happens, and we're going to scope around this and see if we can see any signals. So here goes. Okay, we have voltage, we're drawing about 50 milliamps. We'll press the button. Well, the microcontroller is running. 60 milliamps. Seems about normal. Let's see what we can see. So we know we should have a bit clock. Yes. We should have a word clock. Yes. And data out from the analog to digital. Yes. So if I go to that 5th pin, we should see nothing. That's good. Let's power cycle and just see if we get yeah, okay, so it feels like it takes a little bit longer, but it does stop. And R52, we should see data. Look at that. We see data. There's every chance this is working. So that was the DAC signal that was all screwed up before. That's running. Should we try some audio through it and see if the patient survived? So turn the power off for a second. That's exciting. Hey, there's our dry signal. That sounds like it's running. Don't know what effect I've got on, I'm just but I can hear that changing speed. It may not come across very well on video. That's working. So we've got this 2-position switch. This gives you 2 slightly different tones, I think. Let's get that on the scope, because that's going to be slightly less annoying on the video than that noise. So let's see if we can see the output. I'm not sure if it will. Oh, there we go. So let that come right out. Let's just go dry. Trigger on that. And then if I click it on, you can see modulation. It bloody works. Oh, that's such a relief. What a journey. We're back together. So yeah, easy fix. All it was is the brain and the heart. Easy peasy. Yeah, absolutely no bother at all. You could do that in 10 minutes, 5 minutes if you get a move on. No, that was a nightmare. I'm really happy that that's worked out. As I said, it's not really for the value of this pedal. It's not like it's an especially special pedal or anything, but this just reached a point where I thought I really want to see this through. I know this is a really complicated job, but for one thing it's got going for it is that if you compare it to like that Boss pedal, the phase shifter one that had a dead CPU or DSP in it, well, I couldn't get an off-the-shelf DSP to pop in it to fix it. whereas these NU.X pedals do use off-the-shelf stuff, and they were able to send me schematics, so it's kind of 1-0 to them, really. I think they're pretty well built. I think for what you've got there, you've basically got a little computer inside a pedal. For my needs, they're great for using in the studio for chucking keyboards and occasional guitars and things through. And it's nice to know that even at the most kind of complex fault, they are fixable. I don't know if this is going to last forever. That doesn't really matter. It's kind of amusing that I had to pick up one of its siblings to compare it with, so I've kind of ended up with 2 of them, but that's all good. But anyway, this video has gone on long enough. You've watched me fix a pedal. It's all good to go, so thanks for watching.